Let's continue with question number 9. The equation for the period t of a pendulum with length L is t equals to 2 pi times square root of L over G. Which of the diagrams below best represents data gathered for a pendulum with length as the independent variable and period as the dependent variable? In this question, we were given that t is the dependent variable, like y, and L is the independent variable, like x. And the graph of this equation is like square root of x, because 2 pi is the constant number, g is the constant sum number, so it is like y equals to square root of x, and 2 pi and g is the constant sum number, so we're going to find the graph of square root of x, and square root of x is this. So you need to know how square root of x behaves in the function. The other options are, this is the equation of decaying exponential function. So it is like e to the negative x or negative e to the x. This looks like some either x squared like parabola or increasing exponential function like e to the x. This is the equation of the quarter circle. We know that equation of circle is x squared plus y squared equals to r squared, where r is the radius. And if you solve for y here, then y squared will be r squared minus x squared, and y will be equal to plus or minus square root of r squared minus x squared. This is the equation of the semicircle, where -1 is the lower semicircle, plus is the upper semicircle, like this semicircle is radical r squared minus x squared, and this semicircle is negative square root of r squared minus x squared. But if you would like to graph the quarter circle, you're still going to use this equation, but you need to restrict x and y between the center and the radius for x, and between 0 and the f of x of y. You need to restrict it below this curve and between origin and wherever the radius ends. Let's go to question number 10. Your professor provides you with data from an experiment. You plot the data. It forms a curve of the shape below. You are required to plot the data so it forms a line that you can ultimately determine the slope of the line in order to find the equation of the line. How would you plot the data so that it forms a line? So the equation of this line is x squared, because this is a parabola. So the answer is B. In A, we have 1 over x. The graph of 1 over x is like this. We have asymptotes at 0 on the y-axis and on the x-axis. Equation of square root of x, we have just seen it. It's going to be this. And the equation of 1 over x squared is asymptotic at 0, y equals to 0, like this. And we have also asymptote here. Question number 11. What's the vector sum of vector x and vector y? This is the vector sum, and when we add the vectors, we add tip to tail. So this is vector x, and then we have vector y. We have to add tip to tail, and whenever we are done, because this is only 2 vector, then we connect the start point and the end point. So this is our total vector, total magnitude. And the direction of this vector will be this direction, because the last vector we added is going to that direction. So the answer will be B. A is too short to be the sum of these 2 vectors, so is C. D has the wrong direction, so B is the answer. Question number 12. An airplane takes off from airport A, flies 300 kilometers north, then flies 1,400 kilometers at 45 degrees north of east. After it lands at airport B, what is the closest approximation of the magnitude of the airplane's displacement from airport A? So for this question, we need to know vector addition. The general formula for vector addition is we decompose the vectors. Let's say we have vector f, and vector f has like x component and y component. And let's say we are adding vector 2. Vector 2 has x component and y component. What do we mean by x and y component is the projection on the x-axis and on the y-axis. So let's say we have vector here. Let's say this is f1. So this vector has f1 of x here, which is the x component of this vector, and we have f1 of y. This is the y component of the vector, and this is the vector itself, the magnitude of the vector itself. So this much force is coming from the x-axis and this much force is coming from the y-axis. And when we add the vectors, we add component by component. We decompose vector f into x and y component. We decompose vector y, vector 2, into x and y components, and we add their x components and their y components to get the resulted vector. And the formula to get the x component is whatever the magnitude of vector is. Let's say vector itself is f1 times cosine theta, the angle between the vector and the x component, or the second vector. And for the y component, we multiply the vector by the sine theta, which is the angle between two vectors. Okay, so we're going to use this logic to solve this question. There are other approaches to this question using geometry, special right triangles, but in general, vector addition is we decompose the vectors and add component by component. I have done the diagram already, so let me show that one. Okay, let's simulate this question on the XY plane. This is airport A. We go 300 kilometers to the north. So this is 300 kilometers to the north. And then with the 45 degree, we go 1,400 kilometers to the northeast. So this is like our vector 1, F1. So if we decompose this, 300 times cosine 90 degree, because we go 90 degree to the x-axis. And cosine 90 is 0, 0 times 300 is 0. So x component of this vector is 0. So we have no force on the x-axis. And y component of this vector is sine theta times vector. Sine theta is 1, 1 times 300 is 300. For the second vector, the angle between second vector and the x component is 45 degree. So we multiply by cosine 45 to obtain this number. And sine 45 and cosine 45 is the same value. And if we multiply this value by sine 45, we obtain the same value. Now we know the x and y components of the resulted vector of this purple. And the question is asking just the components, not the total magnitude. But I'm going to show the total magnitude formula as well. So here, going north is representing the total y, and going east is representing the total x components. So total x component is 0 plus 990, which is closest to 1000. So 1000 kilometers through east. So either this or this is answer. C and D is eliminated. And the y component, the total y component, is representing going to north in the y direction. So 300 plus 990 is 1290, which is almost 1300 because we are approximating, so B is the answer. So x and y components of the resultant vector is 1300 kilometers north, which is the y component going to y direction, and 1000 kilometers to the east, which is the x direction. If they were asking what is the closest approximation from point A to point B, then they were asking the resultant vector. Let's call it force R would be equal to total x component squared plus total y component squared in the square root. This is the distance formula actually. So that would be 0 plus 990 the quantity squared plus 300 plus 990 the quantity squared square root, and the answer would be 1626 approximately if you do this arithmetics. So when we decompose the vectors, we multiply vector times cosine theta to find the x component, and we multiply it by sine theta to find the y component of the vector. So we can decompose the vector and add the components. So you need to practice more about vector addition using these formulas. And one more formula before I skip this question. If they are asking the angle, then you're going to use this formula. Angle theta is equal to arctangent inverse tangent, which is also notation like this. Arctangent y over x. So y component over x component, which is, in our case, it would be 1290 over 990 in arctangent. They would give us the angle here. Okay. Next question. Two perpendicular forces, a 30 Newton force directed due to north. So we have 30 Newton due to north and 40 Newton force directed due to east. And this is 40 Newton. Are exerted simultaneously on an object whose mass is 35 kilogram. What's the magnitude of the resultant acceleration of the object in meter over second squared? First of all, the total force is equal to mass times acceleration. So we know the second law of Newton. And here we need to find the resultant total vector. So this is 3, 4, 5 triangle. So this is 50 Newton. We know that the total force on the object is 50 Newton. And we have 35 kilogram mass. So here we can solve for A. In this equation, if you solve for A, acceleration is equal to total force over mass. If you divide both sides on m, you obtain this equation. So here, acceleration is equal to total force we found was 50 Newton divided by 35 kilogram, which is given the mass. And Newton divided by kilogram is meter over second squared. So acceleration will be 1.4 meter over second squared. Okay. So this question was about the second law of Newton, F equals to ma. Here you need to find the total force using the vector addition and then use the formula. Let's go to question number 14. An airplane is flying north with an airspeed of 200 km per hour. When it meets a crosswind of 70 km per hour towards the east, which of the following expression determines the resultant speed of the airplane? So we have again some vector flying to north. With the airspeed of 200 and it meets the crosswind of 70 km per hour towards east. So since these vectors are perpendicular to each other, that they have 90 degrees in between, we can use the Pythagorean theorem. So it will be r is equal to, which is the radius or total distance, a squared plus b squared, and here we're going to obtain 200 squared plus 70 squared, that we're going to obtain this equation C. Question number 15. This time we have vector subtraction. What is the resultant of vector a minus vector b below? So we have vector a, this direction. Since we are subtracting, we have to use whatever b in the opposite direction. So we use b in the opposite direction. This is our vector a, and whatever the position is through the start point is our end. So the resultant vector, we obtain this, and the direction is this direction because b is going that direction. So C is the answer. Whenever we are subtracting two vectors, we use the opposite direction of the second. Question number 16. The graph illustrates the velocity of an object as a function of time. What is the object's instantaneous acceleration at t equals to 5? We were given velocity function and they would like to know the acceleration. So we know that acceleration is the derivative of velocity. So if we find the slope of this line, we find the acceleration, and then we can apply at point t equals to 5. So the slope of this line is rise over run, so like 2 down, 2 right, so negative 2 over 2, so negative 1 is the slope. You can either count from this graph, as you can see it's going negative 1 through the negative direction, or you can pick up two clear points and use delta y over delta x to find the slope. But it is here graphically visually easier to find the slope. Rise over run, 2 down and 2 left, so negative 2 over 2. Now at point 5, since this is linear and the slope is same at every point, so at t equals to 5 it's gonna be still the same. So negative 1 is the answer, because it's the linear line. Question number 17. An object starts from rest at x equals to 0 meter and accelerates at a constant rate, moving from a position of x equals to 0 meter to x equals to 2 meter in 4 seconds. How far will the object move in next 4 seconds? So for this question, let's make a line, and our object is starting from 0th point here and moving to 2 meter here in 4 seconds. And we would like to know where the object will be in another 4 seconds. So another 4 seconds later, where the object will be. So from the first part of the line, we can find the acceleration using the displacement formula, which is delta x is equal to initial velocity times time plus 1/2 at squared. So from here, we know the initial velocity, we know the time, we know the displacement, and we're gonna solve for acceleration. Let's plug in everything. So total displacement is 2 meter, because 2 minus 0, and the initial velocity is 0 times 4 seconds plus 1/2 a times t is 4 seconds, t squared. And if we solve for a here, let's continue here. So 2 is equal to 0 times 4 is 0, and 4 squared is 16. 16 divided by 2 is 8, so that's 8a. So here a is equal to 2 over 8, which is 1/4. So 1/4 meter over second square is the acceleration of the object. And we know that the object is accelerating at a constant rate So the acceleration here will be the same, which is 1/4 meter over second squared. Here we're going to apply the same displacement formula again, but this time we need to know the velocity of the object from 2 meter to point the final destination. So for this, we're going to apply the final velocity formula. Final velocity is equal to the first velocity plus a times t. So we know that the first velocity is 0. Acceleration we solved 1/4 meter over second squared, and we have t, which is 4 seconds. So final velocity will be equal to 1 meter over second. So we know that the object is moving here with the velocity 1 meter over second. We know the acceleration, we know the time. Now we're going to solve for displacement from 2 to unknown. So we're going to apply again delta x is equal to v0 times t plus 1/2 at squared. Now we're going to plug in everything. So initial velocity at this interval is 1 meter per second, and time is 4 seconds because we're calculating 4 seconds later, plus we have 1/2, acceleration is 1/4, and t is 4 seconds squared. So here 4 squared is 16, 16 divided by 4 is 4, 4 divided by 2 is 2, 2 plus 4 is 6. So total displacement is equal to 6 meter. So from here, the final destination is 6 meter. This is the answer. This question also could be solved using the Galileo's law. Let me show that as well. So according to Galileo, the object starting from rest, going with the equal interval, like in our case, we started from rest, which is 0 and 2 meter and unknown, but we were going with the equal distance, like 4 seconds later, another 4 seconds later. So Galileo says whatever the displacement is, which is delta x, will be multiplied by the odd numbers like 1, 3, 5, 7, etc. So the second interval, since the object traveled 2 meters in the first interval in given amount of seconds, at the second interval, same amount of time, it will be multiplied by 3, because the first one is multiplied by 1, second interval will be multiplied by 2. So 2 meter by 3. So 2 meter times 3 is 6 meter. So the object is here at 6 meter. If we had to go another 4 seconds, then the object would be 2 times 5, which is the next odd number that we are multiplying. So 2 times 0, 2 times 1 is here, 2 times 3 is here, 2 times 5 is here, 2 times 7 is the next 4 seconds. Okay, this question is clear. Let's go to question number 18. The slope of a point on a velocity as a function of time. So we have velocity as a function of time. Graph is, so here the slope is always delta y over delta x, so y-axis over x-axis, so which is velocity over time. And we can do dimensional analysis. So the units of velocity is meter over second, and the unit of time is second. So a fraction over another fraction is keep change flip. So meter over second times 1 over second is meter over second squared, and this is the unit of the acceleration, so it's the instantaneous acceleration. So we could solve this question using the dimensional analysis. Okay, let's go to next question, 19. Which of the following could be true of an object moving with constant acceleration? So in this question we're going to analyze the constant acceleration. So in option A, it moves in a circle. If we have circular movement, then the acceleration is the centripetal, and centripetal acceleration is the constant. So this is correct information. And if an object is moving with the constant acceleration, that acceleration could be positive, it could be increasing its velocity. So acceleration can be increasing, which is in the positive direction. Likewise, the acceleration also can be decreasing. You can think that the car is decreasing at the constant acceleration or increasing at the constant acceleration. So the speed can be increasing or decreasing at the constant acceleration. So all three is correct above for constant acceleration. Question number 20. The plot of velocity as a function of time, velocity as a function of time for a moving object is a straight line. Which of the following could be true? So velocity over time is acceleration. We have solved it in the question above. So the slope will be the acceleration. So here we are going to check all possible scenarios of being a straight line in the function velocity and time. So one scenario, the line could be like this, and acceleration is constant because linear line, so the slope is the same at every point. If the line is the horizontal line, then the slope is 0, so the velocity is constant, as you can see from the graph. And if the line is still a straight line at v equals to 0, both velocity and acceleration is 0. So everything is true here, all of the above, because we were not given a specific information about how the line is like horizontal line. We were given information it's a straight line.